A wire loop is rotated in a magnetic field. What is the frequency of change of direction of the induced EMF? To analyze this problem, let's examine how the direction of the induced EMF changes as the wire loop rotates in the magnetic field. When a wire loop rotates in a magnetic field, the EMF induced in the loop changes direction based on the angle between the magnetic field and the plane of the loop. So the EMF is given by Faraday's law as minus d phi by dt, where phi is the magnetic flux through the loop. As the loop rotates, the magnetic flux through it oscillates as a sinusoidal function, reaching maximum and minimum values as the loop aligns with or becomes perpendicular to the magnetic field. In one full revolution of the loop, the EMF will reach a maximum in one direction and reduce to zero, reach a maximum in the opposite direction, and then return to zero. Thus, direction of the EMF changes twice per revolution. Once when it goes from positive to negative and once when it goes from negative to positive. Hence, option A, which is nothing but twice per revolution, is correct because, as explained, the EMF changes direction twice in one complete revolution of the loop.